guys, my name is Aline. Today I'm going to talk about manganese. I will show you its chemical, physical properties and many more. So stay tuned. The element that I choose is manganese. The atomic symbol for manganese is Mn. Its atomic number is 25 and atomic mass is 54.93. It has 25 protons, 30 neutrons and 25 electrons. This is where all the electrons of manganese is placed on every shells. The electronic configuration for manganese is Ar3d5-4s2. It is on group 7 and period 4. The block is D block. The melting point for manganese is 1247 degrees Celsius, while for the boiling point it is 2061 degrees Celsius. The color for manganese is blue, white, and gray tones, generally in a rock shape, especially ore. Powder, on the other hand, is pinkish and very brittle. Manganese doesn't have much function in society, but it is in the foods we can eat, such as nuts, bean, whole grains, seafood, and many more. Manganese also used in stainless steel and power outlets. Guys, for this session, I will explain to you what items that contain manganese. Television circuit board and lithium manganese ion batteries both using manganese to be produced. Manganese ferrite is widely used in electronics and a large quantity goes into producing television circuit boards. As you can see the pictures over here, it is some of the examples of manganese ferrite that used in producing television circuit boards. Soft ferrites for interference substitutions. Ferrites is used because it provides a solution to many problems of conducted and radiated interference. They can be applied almost everywhere, such as shifted on wire or cable as beads, tubes, or cable sheets. The second one is lithium manganese ion battery. For the structure, it has three primary functional components, which are a positive electrode, a negative electrode, and an electrolyte in between. The negative electrode is made from carbon. The positive electrode is a metal oxide. And the electrolyte is a lithium salt in an organic solvent. Lithium manganese ion batteries are notable for their high thermal stability and they are more safe than other types of lithium ion batteries. That is why they are often used in medical equipment and devices and to power traditional phones and laptops. Next is the uses and applications of manganese. First is metallurgical applications. Metallurgical applications includes steel making, aluminum alloys, copper alloys, and metal alloys. The larger consumption of manganese is steel making. Manganese is used for deoxidizing and desulfurizing additives and as an alloying constituent. It can improve the rolling and forging qualities as well as the strength ability of steels and many more. Manganese is probably the most versatile element that can be added to copper alloys. Small additions around 0.1 to 0.3% are used to deoxidize the alloy and improve its castability and mechanical strength. The second large application for manganese is as an alloying agent for aluminium. Aluminium with manganese for around 1.5% has an increased resistance against corrosions. Aluminum manganese alloy also been applied in various products such as beverage cans, kitchenware, and many more. There are also other metal alloys that contain manganese, such as alpha-beta titanium-based alloy, zinc alloy, and magnesium alloy. Manganese can also be added to gold, silver, bismuth, and many more. However, manganese used in these metal alloys is lower compared to other metal alloys. Next is non-metallurgical applications. Non-metallurgical applications includes batteries and chemicals. The most important non-metallurgical application of manganese is in the form of manganese dioxide. which is used as a depolarizer in dry cell batteries. The function of manganese dioxide in batteries is to oxidize the hydrogen and form water. Manganese compounds have been used in many chemical fields. For example, permanganate is a powerful oxidizing agent and is used in quantitative analysis and in medicine, while potassium permanganate is used to purify drinking water and treat wastewater. Other applications of manganese. Manganese phosphatation is used to produce surface filaments, and it also improves wear resistance, prevents welding of metal under load, increases lubrication efficiency, and assures rapid and safe running in moving parts. Health hazards of manganese. Manganese effects occur mainly in the respiratory tract and in the brain. Symptoms of manganese poisoning are hallucinations, forgetfulness, and nerve damage. Manganese can also cause Parkinson, lung embolism, and bronchitis. When men exposed to manganese for a longer period of time, they may become impotent. A syndrome that is caused by manganese has symptoms such as schizophrenia, dullness, weak muscles, headaches, and insomnia. There are a lot of manganese chemical reactions, but at here, I only took 5 examples of manganese chemical reactions. First is reaction of manganese with acids. Manganese dissolves readily in dilute sulfuric acid, forming a colorless solution of Mn2 ions and hydrogen gas. This is the chemical equation of this reaction. Second is reaction of manganese with oxygen. Manganese is not very reactive in regards to air. The surface of manganese lumps oxidize a little, finely divided manganese metal burns in air. As you can see the chemical equation over here, the oxide Mn3O4 is formed and the nitrate Mn3N2 is formed. Third is reaction of manganese with ammonia. Manganese 2 ions are precipitated by ammonia as manganese 2 hydroxide. The precipitation is incomplete. This is the chemical equation for this reaction. Next is the reaction of manganese with hydroxide ion. Manganese 2 ions are precipitated by hydroxide ions, forming white precipitate. This is the chemical equation of this reaction. This is the reaction of manganese with peroxide. As we can see the chemical equation over here, Mn2 ions are readily oxidized to MnO2 by hydrogen peroxide under alkaline conditions. The general rule for manganese compounds reacting with a surplus of hydrogen peroxide under acidic condition is the oxidation to Mn2. Under alkaline conditions in a surplus of hydrogen peroxide, MnO2 is formed. This is the last section of this video, which is the importance of manganese to our daily life. The human body cannot produce manganese, but we can store it in the liver, pancreas, bones, kidneys, and our brain. Usually we obtain manganese from our diet. The health benefit of manganese is supporting bone health, healing wound, reducing blood sugar, and providing antioxidants. Besides health benefit, manganese that used in the making of battery, television circuit board, aluminum alloys, and many more is very important to human. Without manganese, unstable and shorter lifespan of product may be produced, which can cause more harm to human. Manganese is also important for forensic science field. Manganese that being used to produce battery is very useful to forensic science, as the battery that produced has higher thermal stability and safer than other type of lithium-ion batteries. Many forensic equipment is using the lithium manganese ion batteries so that those equipment can be used for a longer period of time. This is the example of the item that contain manganese, which is the battery itself on the circuit board. So I hope you enjoy watching this video, and thanks for watching.